With the next video. In the last video, we have completed up to alkyne nomenclature. Now we will do, after alkyne, alcohols. Alcohols is having general formula CN H2N plus 1 OH. Now this OH is known as the functional group. Now how this alcohol comes, like first if we take N is equal to 1, so we have CH3OH, that is we have CH, this is called methanol. This is methanol. How this comes? It comes from methane. You see, this is our methane. If we replace this hydrogen with OH, so it is methanol. Now if we take N is equal to 2, so we will have C2H5OH. That is from ethane it comes ethanol. Our ethane is this. So it is ethanol, CH3, CH2OH. We can write it in this manner, CH3, CH2OH. This is ethanol. Mind that we are naming it with all. The last one, all. And here the functional group is OH. Then we have N is equal to 3, that is propanol. That is CH3, CH2, CH2OH. This is called propanol. Now next, we will do aldehydes. Next we will do aldehydes. The functional group here is CHO, that is C double bond OH. Like the first member is N is equal to 1, that is we will write it as CHCHO, not OH, because this is aldehyde. So we have methanal, Al. Aldehyde is Al. Then N is equal to 2, that is C bond C, that is CH3, so it is double bond OH. Again we have CH3CHO, ethanal. Then we have N is equal to 3, that is we have C bond C, so it is that is CH3 CH2 CHO. This is called propanal. By the way, this methanal is known as formaldehyde, its common name. Formaldehyde. And this ethanol is known as acetaldehyde. And the next we have ketone. After aldehyde we will having ketone. That is, the functional group is this. So it is C bond C bond C. It starts with N is equal to 3. So this middle one is CO and this is CH3 CO CH3. That is propanone. This is propanone. Then we have butanone. Here the C double bond O is always between two carbon atoms. So it is CH3, CH2, CH3. That is we have butanone. Okay. Like this we will have pentanone also. It is one, O-N-E, one. O-N-E, one. Ketone, we will do it as one. O-N-E, we know that one, but here we say it as one. Then CH, 1, 2, 3, 4, 5. So we will have CH3, CH2, CH2, CH3. Then we will have, after ketone we have ether. Ether is very important. Ether. How does it happen? COC. This O is the functional group. So how does it occur? CH3O CH3. Why? Always we will fill up the 4 valency of carbons. Okay. So it is CH3O CH3. Clear? Next we will have, this is the name is methoxymethane. Then we will have ethoxyethane. This is ethoxy and the parent name is ethane. Now if we have CH3O CH2 CH3, then we will say methoxyethane. That means we will always choose the longest chain as the parent name and methoxyoxy as a substituent. So it is methoxyethane. Not that we'll take it right-wise or we take it left-wise, not that way. We will see the longest chain here. So this is ethane and we will have methoxyethane. Then we will do, after ether, this is called ether, or we can say it as dimethyl ether. Very common, dimethyl ether. And if we have here that one, this is common name. Diethyl ether is the common name. So this is also the common name. So we must practice this as ether. And finally the carboxylic acids. Carboxylic acid means we will have this as the bonding, that is COOH, two O's, two oxygen. One is double bonded O and other is OH. So the first member when N is equal to 1 is HCOOH. That is, this is normally called formic acid, which is the common name. But its IUPAC name is methanoic acid, that is oic acid. And then we have N is equal to 2, that is C bond C, that is COOH, H, 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 that is CH3COOH, that is ethanoic acid. And if we have ethanoic acid, our very common name is acetic acid. This we must have known all. This acetic acid, which is known as ethanoic acid, see, oic acid. And then if N is equal to 3, we will have C bond C bond C. That is, this last one will take as COOH, the terminal carbon. And this is CH2 and this is CH3. So we will have CH3, CH2, COOH. This is called propanoic acid. Oic acid, propanoic acid. Likewise, we can say butanoic acid, pentanoic acid. Okay. So next we move on to esters. Ester naming is not included in your class 10 syllabus, class 10 ICSE syllabus. So we need not have to bother so much. But still, one for example we will show you. That is ester. Let me see how the ester forms. Ester actually forms by acid and alcohol. This is very famous reaction, esterification, in your class 10 syllabus. That's why you have to know the ester. What is it? It is the combination of acid and alcohol. Just like we have acid and base give salt and water, here it is acid and alcohol, which gives this one and this one goes off, and we will have CH3, COO, C2H5. Mind that, CH3, COO, C2H5. Now while naming, we will take it as the first. Ethyl and ethanoate plus water. This reaction is known as esterification and this compound is known as the ester. It has a fruity smell. It's really having a fruity smell, very sweet smell. So this is the formation of ester. Now which is required is we must have the idea of haloalkanes, halides. Like we have haloalkanes, so this is CH3Cl, means chloromethane or methyl chloride. Chloromethane or methyl chloride. Now we can have ethyl chloride. So this is CH3, CH2Cl, that is chloroethane. Chloroethane. Now, if we have more chlorine atoms, then how will you name? Suppose this is one chlorine atom, here it is another chlorine atom, and others are hydrogen. So we will say it as 1, 2, that is 1, 2 dichloroethane. 1, 2 dichloroethane means one chlorine is the first position, first carbon, and other chlorine is in the second carbon. So it is 1, 2 dichloroethane. Then we will have 1, 1. We can have that. This position and this 1, 2 naming is very important in organic. This will actually give the address of the molecule. Like if we have C bond C and chlorine is on the same carbon, then we will say 1, 1 dichloroethane. Okay. 1, 1 dichloroethane. So in this way we can go on with saying the halides. Now if we say halides, then we will move on to just almost finish. With chloro we have done this nomenclature. We can do it similarly with bromo. Now let us do isomerism. What is isomerism? Having is the fact or is the phenomenon having same molecular formula but different structural formulas. Same molecular formula and different structural formulas. Like if we have C3H8, this is our propane. So what we can do is, this is propane, sorry, for propane, with propane we do not have, we will have it with butane, that is C4H10, that is butane. So with butane we will have so we are having CH3, CH2, CH2, CH3. Then we will have C bond C and make another carbon here. So we will have 1, 2, 3 here, and already 1, 2, 3 are here, so this carbon will get only one hydrogen. Again this carbon will get 3 hydrogens, and this will also get 3 hydrogens. So ultimately we will have CH3, CH, CH3, CH3. That is 2-methyl propane. 1, 2, 3. In this way we will numbering it. From this side we can do, or from this side also we can do. 1, 2, 3. In both the sides we get 2 as the middle position. That's why the name is 2-methyl propane. Actually our motto is to get the lowest number in the substitution. This is the main chain. This is called the main chain. And this is the substituent. So we get the name 2-methyl propane. So here butane have 2 isomers. One is N-butane. This is called N-butane or normal butane. N stands here for normal or normal butane. You may tell it normal or not. That is N means single chain. No substituents. N-butane and then 2-methyl propane. Then in this way we will have C5H12, which can also have isomers. These are all called chain isomers. Chain isomers. There is a difference in the chain. See, this is also C4H10, 3, 3, 6 and 4, and here also C4H10, 3, 3 is a 9, 1, 10. So this matches, that's why we can say it, this is as a isomerism. Then we will move on to we have done chain isomerism. Then we will do our position isomerism. How is this? Suppose we have propanol. Propanol. That is C1, 2, 3. This is OH. CH3, CH2, CH2OH. So this is one propanol. 1, 2, 3. This must be one. Propan 1 all or one propanol. And next we have that is we are having CH3, CHOH, CH3. This is our 2 propanol. 1, 2, 3. So it is propan 2 all. That means the position of all is changed. So it is propan 2 all. Okay. So this is propan 2 all. In this way we can get the position isomers. Also the position isomers occurs for alkene and alkynes. Like we have butane. Butene. 1, 2, 3, 4. So 1, 2, 3, 4. So this is but1ene. Then we are having 1, 2, 3, 4. So it is 1, 2, 3, 4. Between 2 and 3, so it is but2ene. So this is also position isomers of butene. Likewise, we have butane. Here also we can have it. C, bond C, bond C. So it is but 1-ine, and we can have but 2-ine. It is in the 2 position between 2 and 3. That's why we will take the 2. That is the lowest number. Here it is 1 and 2. Between 1 and 2. That's why we will take 1-ine. Clear? So this is all about the isomerisms are there in your class 10 syllabus. Then detailed discussion will be on this isomerism will be in class 11 syllabus. We will do it then. So till here isomerism completed.